So in our last video, we talked about using factoring to solve puzzles. What happens when we have a quadratic equation like x squared plus 6x plus 2 equal to 0, where we don't have whole numbers that we can add together to give us 6 and multiply to give us 2? Well, this is where a very important method comes to play. So today I'm going to show you how to use completing the square to solve any quadratic equation, no matter how messy it wants to be. So let's go. So I'd like you to picture x squared like, well, a real square. So to make this square to be perfect and balanced, we need to add that small piece and then it becomes a complete square. And that is actually the method of completing the square, because we are literally finishing the geometry. All right, so here's the step-by-step secret. If you look at that middle number 6, which is the coefficient of x, one of the steps we are going to take is, first of all, we are going to divide that middle number 6 by 2, and then the second step is to square that number. So when we divide that number by 2, we'll get 3, and when we square 3, we get 9. So 9 is the magic number. It is the missing piece of the puzzle, the piece that once we place the square will be completed. So we add 9 to that part to complete the square. But don't forget that this is an equation. So whatever you do to the left hand side is exactly what you have to do to the right hand side. So now that you have added 9 to this side, then you must add 9 to the other side. All right, so now the left hand side is a perfect square. And so we are left with minus 2 plus 9 on the other side, which will give us 7. So all that is left for us to do is to find the square root of both sides, and we will get our answer. Okay, so before we wrap this all up, I would like us to work an example together so that, let the whole concept sink in a little more. All right, so let's get to the screen. All right, so we have this on the screen. It says solve x squared plus 10x plus 7 equal to 0. So if you look at this, you will realize that you cannot use the factorization method. You cannot look for any two numbers such that when you add them together, you get 10, and when you multiply them, you get 7. And even if you have such a number, they are not whole numbers, so you can't do that. So this is completing the square method trick. So the first thing you must do is to move this plus 7 to the other side of the equation first. So what we have is x squared plus 10x equal to minus 7. So that's the first step. So we are left with x squared plus 10x in the left hand side of the equation. So the next thing we need to do is to find out the coefficient of x, dividing it by 2, just like we said earlier, and then squaring it. So when we divide this by 2, what we have is 5 squared, and 5 squared is equal to 25. So that means that what we are going to add in the left hand side of the equation is 25. So we have x squared plus 10x plus 25. But whatever you do to the left hand side, you must also do it to the right hand side. So what we have here is minus 7 plus 25 as well. So let me just clean this up so that it doesn't get on the way. All right, so this is what we have. All right, so this right here is already a perfect square, because this is the same thing as x plus 5 all squared. So we have done that, and minus 7 plus 25 here is 18. So what we have is x plus 5 all squared equal to 18. So the next thing we need to do is to find the square root of both sides, and the reason why we are doing that is so that we'll get rid of this square here. So let's do that. So when we find the square root of both sides, we have square root of x plus 5 squared is equal to square root of 18. So this cancels this, so the square is gone. So what we have is x plus 5 equal to the square root of 18. And whenever you are dealing with square roots, it is either plus or minus, because whatever it is you have as square root can either be a negative number or a positive number, so it doesn't matter. So you have to use that just to make it clear. Now when we move 5 to the other side, so I will have x standing alone, which is what we're looking for. We have x equal to plus minus the root of 18 minus 5. So this is what we have, but I'm not very comfortable with this root of 18. We can still simplify it. We can still break it down further. So this implies that x is equal to plus or minus. This is the same thing as saying 9 times 2 minus 5. And this is, of course, 9 has a square root, so the square root of 9 is 3, so it comes outside. So this is plus or minus 3 root 2. So root 2 is still inside the square root, or rather 2 is still inside the square root, because 2 doesn't have a perfect square root. So this is minus 5. So let us shuffle this all shuffle this so it will look good. So we have minus 5 plus or minus 3 root 2. So that means that x is equal to minus 5 plus 3 root 2 or minus 5 minus 3 root 2. So these are the two solutions that we have for this question right here. Okay, so I hope it's very clear right now. I believe that with this example everything is now a-okay. So now you have a trick, you have a method that you can use even when the factoring method fails. But here's the thing, what if your quadratic equation is even messier and even uglier than even this one? So that is what our next video is all about. The next video we're going to be talking about the big boss, the one and only method that can handle any quadratic equation that you can throw at it in this world. So I'll be seeing you in the next video for the big boss.